In this video, we want to find the exact solution to this exponential equation here. So we're going to use properties of logs. Here are some of the properties we have. Understood that all the bases have to be positive, not equal to 1. And here are some of the properties we're going to use. If m is equal to n, if these are two numbers, m and n here are positive, you can take the log of both sides. Log of m to base a, whatever base you pick, is equal to log of n to base a, if that's the base you pick. And then this one here, the log of m to the r to base a should equal to the r, or the exponent becomes a coefficient, r log of m to base a. You have the difference of logs here, log of m to base a minus the log of n to base a. That becomes the log of m over n to base a. Have a similar one for product here. Hopefully you've seen these properties before. So let's go. So here we have two positive numbers equal to each other. So we can take the log of both sides to any base, as long as it's defined. The base has to be positive and not equal to 1. And we still have equality. So we can pick base 10, log to base 10 rather. We can pick natural log where the base is z. You can pick another base. Now normally we go with the natural log or the log to base 10. I'm going to use natural log here. We want to solve this. This is an exponent, so again, using the property for exponents, this becomes a coefficient over here. So I can write this as 3x plus 1 should equal to natural log of 7. Make sure you have this in parentheses here. And right side, same thing. This properties of logs allow me to take this exponent and make it into a coefficient. So this will be x ln of 5. On the left side, we just simplify through, so multiply through by ln of 7. This will give me 3x multiplied by ln of 7. Then 1 times that is just ln of 7, so it can be a plus ln of 7. That's equal to x. On the right side, ln of 5. Now I'm going to collect the terms with an x. So this has an x, this has an x, so this is going to come over, become a minus. And the ln of 7 doesn't have an x, that's going to go over here, that's going to change signs. So this will give me 3x ln of 7. And then the other one, term on the right comes over, change the sign, so it'll be minus x ln of 5. The ln of 7 goes to the right side, change the sign, minus ln of 7. So here I have an x, and here I have an x, so I want to isolate the x, so I just factor out the x here, and that leaves me with 3 ln of 7 minus ln of 5. And that's equal to minus ln of 7. So I'm going to divide both sides by this expression right here. That's just a number. So dividing the left side by that will cancel it. So this will just give me an x over here. And the right side, then I'll have minus ln of 7 divided by this expression here. And as I move it over, I'm going to rewrite it. So this coefficient here will become an exponent. So it'll be 7 to the third there. So this will become properties of logs again. ln of 7 to the third. And that's minus ln of 5. And this is equal to. Now if you were going to give an exact, an approximation, you could go ahead and just do the calculation here and get the answer. So from here then I can rewrite this as minus ln of 7. And then here I have the difference of two logs, so I can write this as the natural log of 7 to the third over 5. That's again property of logs. So 7 to the third is 343. And that's over 5. Now this is your exact answer. Minus ln of 7 over ln of 343 over 5. That's the answer. Now, if you had one where it said Same problem, said one at approximation to 2 decimal places. Then you could use your calculator here, compute the negative natural log of 7 and divide it by the natural log of 343 over 5. And this should come out to a negative 0.46. But that's your solution there. Thanks for watching. We'll see you next time.